Okay, let's start today's session. Okay, last week we did about applications of derivatives. Then today I'm going to do specially how to sketch graph using differentiation. This is really important part because section number 14 part A will be graph with differentiation. So we have different analysis with differentiation, limits and so on. When sketching function, we can use differentiation to find gradients. We can use differentiation to find gradients. That's the thing. Okay. Then we need to analyze that how to get it. Okay. Just write down first. Sketching graph by differentiation. Sketching graph by differentiation. Sketching graph by differentiation. Sketching graph by differentiation. Okay, now see this. So under application of derivatives, I introduce little things. So here you consider here a function x-axis, y-axis, it goes like this. So here the specialty as x increasing, y increasing, as x increasing, y value increasing, we call increasing function. Then all are increasing functions. So for increasing function, we have special property dy by dx or f dash x positive. Here the special property for increasing function dy by dx greater than 0. Dy by dx or f dash x positive. That is for increasing functions. So here each case dy by dx positive, f dash x positive. And for this case f double dash x 0. And for this case f double dash x, here we call concave up positive, and for this case we call f double dash x negative. Here we call concave down. Here concave up, here concave down. For each case, for increasing function, surely derivative positive. Positive first derivative. Then second derivative can be different. Here we call concave up. And here this is equal concave down. That is for increasing functions. So derivative represent its gradient. No? Now further, you consider this. Here x-axis, y-axis. You consider a graph like this. So as x increasing, y decreasing. We call that is decreasing function. Okay, previous one increasing function, now this one decreasing function. Then thereafter, here we call decreasing function. Here specialty dy by dx or f dash x, we say negative. Then to find increasing region, you have to check dy by dx greater than 0 region. If you need to find decreasing region, you have to get dy by dx negative region. That's how we find increasing, decreasing regions. Okay. Then further, here each case dy by dx positive, no? Sorry, negative. And here this is concave down, then we call f double dash x negative. Here f double dash x 0, and here f double dash x concave up positive. Then here we call concave up, same thing we have. Same thing here we have. Here concave down, same thing we have here. Concave down, concave up, and here concave up, concave down. Anyway, we have especially two things. One is increasing, the other one is decreasing. Then to obtain increase in function, you have to check derivative whether it is positive or not. So for decrease in function, derivative negative. That's the thing. Okay. So in each function can have increase in region and decrease in regions. Increase in regions and decrease in regions. Okay. Write down this one. The first derivative of the function, represent gradient of the tangent at a certain point. Gradient of the tangent at a certain point. Gradient of the tangent at a certain point. At a certain point. First star mark. When dy by dx equals 0, then the function is a constant function. When dy by dx equals 0, the function is a constant function. Next star mark. When dy by dx greater than 0, the function is increase in function. When dy by dx less than 0, when dy by dx less than 0, then the function is decrease in function. Okay. Now sketch all and write them. Okay. Now let's move further. Write this question. Write this question. Find increase in regions and decrease in regions for the following functions. Find increase in regions and decrease in region for the following function. Find increase in region and decrease in region for the following function. Following functions. Okay, I'll do example. So here y equal x square minus 2x minus 5. When function increase in derivative positive, when function decrease in derivative negative, that's the thing. Okay, you differentiate first. Dy by dx, 2x minus 2, take 2 outside, x minus 1. Then dy by dx greater than 0 case, 2 into x minus 1 greater than 0. No? Here linear inequality, x greater than 1. Here this is equal increase in region. Then dy by dx less than 0 mean 2 times x minus 1 less than 0. Then we get x less than 1. Here increase in region, here decrease in region. Increase in region and decrease in region. Okay, very simple thing. Okay, do that example. Then when considering sign, you differentiate and factorize. Huh? Here differentiation, then factorization. Factoring. So then only we can analyze its sign. So first you differentiate, then factorize, then check dy over dx greater than and dy over dx less than regions. Say another example. Y equal x cube over 3 minus x squared. Then dy by dx 3x squared over 3 minus 2x. Then take x outside, x minus 2. Here are the factors. Then dy by dx greater than 0. You solve this. X into x minus 2 greater than 0. That is quadratic inequality. No? We have factor 4. Then we can easily evaluate this inequality. For this case, here 0 value 0, here 0 value 2, then positive region here and here. Then x less than 0 union x greater than 2. Yeah, increase in region. Then dy by dx less than 0, negative region, x into x minus 2 less than 0. Then here 0, here 2. Here negative region. Therefore, x in between 0 to 2. X in between 0 to 2, that is decrease in region. Okay. Then very simple. The concept, you check dy over dx greater than 0 region and dy over dx less than 0 region. Very simple thing. Then finally it convert into inequality that can be linear, that can be quadratic. Then you have to analyze that. Okay. Do it. Okay, you try this. Try this. Take the time. Okay, here dy by dx 8x minus 16 x minus 2. Then dy by dx greater than 0, x minus 2, 8 into x minus 2 greater than 0, x greater than 2. Here increase in region. Then decrease in region, dy by dx less than 0, 8 into x minus 2 less than 0, x less than 2. Here increase in region, here decrease in region. Then here, this is somewhat special. Let's take derivative. Dy by dx minus 3 times x minus 1 square. Then you have to check dy by dx greater than 0 first. Then minus 3 times x minus 1 square greater than 0. We don't have any real value, no? Here this is positive into minus mean negative. Then all are negative. Then here no decrease in region, no increase in region, no increase in region, no increase in region. Then dy by dx less than 0, dy by dx less than 0, minus 3 times x minus 1 squared less than 0. Here when x equal 1 it is 0. Then all the other cases dy by dx negative, no? Then here any real value without 1, any real value without 1. Then here no increase in region, here decrease in region, without 1 all are increasing. Sorry, without 1 all are decreasing. Okay. Then here decrease in region. Then here this case dy by dx 5x to the power 4 over 5, 3x square over 3, take x square outside, x square minus 1, you factorize further, x minus 1, x plus 1. Then take dy by dx 0, greater than 0. Then here x into x square into x minus 1 into x plus 1, greater than 0, greater than 0. Then here positive this part, then you have to check only this x minus 1, x plus 1 greater than 0. Okay. Then here minus 1 plus 1 range. Here positive region, positive region, positive region. Then increasing region x greater than 1, x less than minus 1. No? Then x greater than 1 union x less than minus 1. That is increase in region. Then definitely dy by dx less than 0, the remaining region. No? The remaining region. X in between minus 1 to plus 1. Here decrease in region. Here increase in region. Increase in region. So anyway, you differentiate the function and dy by dx positive region increasing, dy by dx negative region decreasing. Okay. Okay, complete. Here one another thing, when x equals 0, dy by dx not negative, it is 0. No? Then you have to exclude here x not equals 0. Union x not equals 0. Huh? So you have to exclude x equals 0. So within this region 0 is there. No? Then here x square value, when x equals 0, this part gets 0, that is not decreasing or increasing, then we have to exclude that. Huh? Okay. Now let's move to graph sketching part. Graph sketching part. Now for your A levels, definitely you will get rational type function to sketch. Okay, rational type function to sketch. Then, but we have to analyze both rational type and polynomial type as well. So at first, I'm going to analyze how to sketch polynomial functions. So we know how to sketch line, straight line, and quadratic function. We know how to sketch, and further we have cubic, biquadratic, and so on. So anyway, so we have to practice sketching polynomial function and sketching rational function. So when sketching these functions, we have to analyze special points first. We have to analyze special points. So there are a few special points. So one we call critical points. First one we call critical point. Second one we call point of inflections. So by differentiation, we can analyze them. We can track it. Critical points. There are 4 different types of critical points. Especially there are 2. One is called turning, the other one is inflection. Turning and inflection points. We have 2 special things. So under turning points, we have again 2 another thing. Minimum and maximum. So under inflection point, we have increasing inflection and decreasing inflection. Then altogether we have 4 different cases. 4 different cases. Let's see what are the specialties here. Let's see what are the specialties here. Now, before that write down. Here we're going to analyze. Sketching functions. Here we're going to analyze sketching functions. Mainly concern about first one polynomial function. First one polynomial function. First one polynomial function, second one rational function. First one polynomial function, second one rational function. With star mark write down. For polynomial functions, there are critical points. For polynomial functions, there are critical points. For rational function, there are critical points and asymptotes. A S Y M P T O T E S. Asymptotes. Okay. So now for polynomial we have critical point, and for rational function we have critical point as well as asymptote. But there can be asymptote. There sometimes they won't. Okay. Okay. Let's see what are they. Let's see what are they first. Okay. Under that, write down further. Especially there are two different types of critical points. Especially there are two different types of critical points. First one, turning points. First one, turning point. Under that, write down local maximum point or local minimum point. Local maximum point or local minimum point. Two, point of inflection. Second one, point of inflection. Point of inflection. Under that, write down increasing inflection and decreasing inflection. Increasing inflection and decreasing inflection. Increasing inflection and decreasing inflection. Okay. Now here are they. See this one. Here maximum, here minimum, here concave down, then it changed to concave up. Then here increasing inflection, here concave up, then concave down change. Here decreasing inflection, increasing inflection. Here local minimum, local maximum. So at this point when you sketch a tangent, that the specialty, they are parallel to x-axis, na? They are parallel to x-axis. Here it is. Here decreasing inflection, increasing inflection, turning points. Here these two turning points. And here point of inflection. Turning point, point of inflection. Here local maximum, local minimum. Increasing inflection, increasing inflection. Here decreasing inflection. Decreasing inflection. Okay, all together we call critical points. All together we call critical points. Yeah, critical points. Critical point. Okay, first sketch them. Sketch them. Okay. So when you consider critical points, there's one common thing, that is when you sketch a tangent at that point, that tangent parallel to x-axis. That means first derivative 0, no? Gradient 0. Gradient 0 means we can identify as a critical point. So here critical point dy by dx equals 0 for all critical points. All critical points. Okay, put that as well. Okay, now right here, to identify a critical point, first check first derivative. First check first derivative. First check first derivative. First check first derivative. And factorize it. And factorize it. And factorize it. Then solve. Then solve. Then solve. Dy by dx equal 0. Then solve dy by dx equals 0. The corresponding values are critical values. 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 Those values can be substituted to the function. Those values can be substituted to the function. Those values can be substituted to the function to obtain critical point. To obtain critical point. Okay. Now see this example. You consider y equal 2x square minus x. Then differentiate dy by dx 4x minus 1. Then solve dy by dx 0 case. Then 4x minus 1 0. Then x value 1/4. No? Here this is equal critical value. Critical value. Then find corresponding y value. You substitute that value here. 2 into 1/4 square, 1/4. Here 2 over 16, 1 over 8, minus 1/4, minus 1 over 8. Then we know x value, we know y value. Then corresponding point we call 1/4 comma minus 1 over 8. No? That is we call critical point. Then very simple concept. So here the function, you differentiate it and equate to 0 and solve it. Then here the corresponding solutions we call critical value. There can be different 1, 2 or 3 critical points. There can be many critical points. Then you take this critical value and substitute to the function, you can take corresponding y value. Here corresponding y value. Then here at 1/4 corresponding y value minus 1 over a. That point we call critical point. Here this value we call critical value. So still we don't know whether it is maximum, minimum or increasing inflection, decreasing inflection. But we can identify that is a critical point. So later we can find how to identify critical point, how to classify critical point. Okay, later we'll see that. Okay, this is the way, that's how we identify. Do it. Okay. Now let's do another example. Y equal x cube over 3 minus x square over 2. Then differentiate dy by dx. 3x square over 3, 2x over 2, then x square minus x. You better factorize this, x into x minus 1. Here differentiation, then factor form here. Factor form very important because later we need to find critical point. Therefore we have to equate to 0. Then to solve, factor form is the best. Again later we need to analyze sign of this derivative. Therefore factor form again the best option. Therefore the procedure you identify, differentiate, then factorize. Thereafter you do anything. Okay, first differentiate, then factorize. Then now solve dy by dx 0. Here you have to remember, to identify critical point you have to solve dy over dx 0. X into x minus 1 0. Then here we have x equals 0 or x equal 1. Then we have two critical values. Then take corresponding point, substitute 0 here, then we get 0. Then 0, 0, one critical point. You have to substitute this x0 to here. Then similarly, x equal 1 to here. 1/3 minus 1 over 2. Minus 1 over 6. Then corresponding point 1, minus 1 over 6. Then these 2 points we call critical points, no? Critical points. We have two critical points. So later we will see how to classify them. Do up to that. Okay, you try this. Y equal x to the power of 4 minus x square over 2. Try this. Here we have 3 critical values. Then corresponding y value you check. X equal -1, here 1/4 minus half -1/8. X equals 0, y value 0. X equals 1 again, -1/8. Then -1 comma -1/8, 0 comma 0, 1 comma -1/8. Here critical points. Here critical values. Critical values. One over 4. Not 1/8, 1/4. X equals 1, 1/4 minus 1/2. Then minus 1/4. Critical point. Okay. Now with star mark write down. With star mark write down. With star mark write down. To identify a critical point. To identify a critical point. To identify a critical point. About the critical point, about the critical point, about the critical point, sin f of the derivative, sin of the derivative, sin of the derivative can be analyzed. Sin of the derivative can be analyzed. Okay. We check one. Here first local maximum. Here is get tangent. Here tangent. X equal a. X equal a. X equal a. Now here x equal a. Here take this point. X equal a minus delta. And take this point x equal a plus delta. X equals a plus delta. Okay. Then when you sketch tangent here positive gradient. When you sketch tangent here negative gradient. No? Therefore, dy by dx at x equal a, when you substitute x equal a, you will get 0. Dy by dx at x equal a minus delta, a minus delta, positive gradient. Then dy by dx at x equal a plus delta, negative gradient. Negative gradient. Therefore, when you come from here left to right, so we have to increase, then decrease, no? Then for this region, increase in function, and for this region, decrease in function, decrease in region. Then here increasing, then decreasing. Then dy over dx positive, 0, negative. Dy over dx positive, 0, negative. Then increasing, decreasing. Gradient positive, then 0, then negative. Then dy by dx variation about critical point. About critical point, positive to negative variation, na? Positive to negative. Positive to negative variation. Positive to negative variation. And further, it go through 0, no? Here positive, 0, negative. It go through 0. That's how we identify. Then before negative, positive, after negative. So if you consider minimum point, then opposite of that, no? Negative, 0, positive. Then opposite of that, minimum. Opposite of that, minimum. Then increasing inflection, positive, 0, positive. Negative, negative, 0, negative, decreasing inflection. Likewise, you can identify critical points. Okay. Put this on. Identification of local maximum. Identification of local maximum. Here this part, very important section in differentiation. So at least you will get 8 mark out of 100. Then very simple one, we have to analyze only few things. Only few things. Huh? Very simple questions. Then we can't miss it. Then analyze properly. Identify the thing. Okay. That's how we analyze local maximum point. Okay, local maximum point. Similarly, you can identify local minimum. No? Local minimum. Now you do with me. Do with me. Now here the graph. Here at x equals a plus delta, x equals a minus delta, then a minus delta negative, here 0, here positive. Then dy by dx variation above critical point, here negative to positive. Negative to positive. About variation about critical point, negative to positive. Usually we go left to right, okay? We go left to right. So when we move in left to right, here decreasing, then increasing. Decreasing, increasing. Therefore negative gradient, 0, positive gradient. Then negative dy by dx equals 0, positive dy by dx sign. That is local minimum. Local minimum. Put that one. Okay. Now let's see increasing inflection and decreasing inflection as well. Increasing inflection and decreasing inflection. Do with me. Do with me. Here increasing inflection, it goes like this. Then at here, dy by dx 0. So before that, positive gradient. After that, again negative gradient. Sorry, positive gradient, both positive. Then here positive, 0, positive, dy by dx variation about critical point, positive to positive through 0, positive to positive through 0. Okay, that is increasing inflection. Increasing inflection. Okay, then decrease in inflection. Concave up, concave down. At here, tangent parallel to x-axis, therefore at x equal a, 0 gradient, x equal a plus delta, negative gradient, x equals a minus delta, negative gradient, negative gradient. Here both negative. Then negative to negative variation through 0. Negative to negative variation through 0. Then by considering sign of dy over dx about that critical point, we can identify what is that point. Okay, we have to check the sign. That's it. Very simple thing. So now, when identifying critical point, first you have to differentiate, then you have to factorize, then you have to equate to 0, no? Then solve, then obtain critical values. Those values you can substitute to the function and obtain y value. Then we can get corresponding critical point. Okay, that is critical point. Then to identify critical point, you have to check this sign. You have to check the sign. dy over dx sign about that critical point. Okay, now let's do example. Write this question. Write this question. Identify the critical points of the above examples. Previous one, I gave 4 things now. So one is x square minus 2x plus 5. No need to do from the beginning now. You can take previous thing. X square minus 2x plus 5. Here we did dy by dx 2x minus 2 factorize. Then we have to get dy over dx 0 cases. 2 into x minus 1 0, x equal 1. X equal 1. Then take corresponding y, substitute 1, 1 minus 2 plus 5, 4. Then critical point 1, 4. We done up to that, no? We done up to that. Now further part, we have to check dy over dx sign. Here this is the part. dy by dx sign. You have to check this one. Identify this one properly. Now here we have critical value now. We have one critical value. So that critical value mark on a number line. That critical value 1. And identify the region here, greater than 1, here less than 1. Those are the region. Then for greater than 1 region, here greater than 1 region, surely dy by dx positive, no? Sign positive. Therefore, you put the sign positive. Then x less than 1 region, when you get any value less than 1, we get negative value. No? Then dy over dx negative. Then you go from left to right. So negative to positive variation. Negative, 0, positive. Here at 1, 0. Dy by dx 0. Therefore, negative to positive variation you identify as minimum. No? Then you say here this point 1 comma minus 4 is a local minimum point. That's how we identify. Then no need to do all, you know these things now. You can get this relation result. Thereafter you check the sign about that point. Okay, do it. Okay. Now take another example. Take another example. Second one, x cube minus 3 over x square. X cube over 3 minus x square. Okay. Y equal x cube minus 3 over x squared minus x squared. Okay, you follow the procedure. Dy by dx 3x squared over 3 minus 2x. Take x outside, x minus 2. Then dy by dx 0. Solve. X into x minus 2 0. X equals 0 or x equal 2. When x0 y value, x0 y value substitute here 0. x2 y value 8 over 3 minus 4. Minus 4 third. Then critical point 0 0 2 minus 4 third. Critical point. We have two critical points. Here critical values. We have two critical values. Here we have corresponding critical points, two critical points. Okay. Then now to classify them, we have to check dy over dx sign. So when checking sign, you need to do this say, here we have two critical values now. Mark them on a number line. One is 0, the other one is 2. Likewise, you mark them and get a table like when we are doing inequality. Critical value 0 and 2, mark them on number line. Now we can identify the region. Here greater than 2, in between 0 to 2, less than 0, here the region. Now you need to check dy over dx sign. Here dy over dx, we can take that from here. So we have dy over dx in factor form, then we can identify sign. Then greater than 2, you take some value greater than 2, substitute here, we get positive answer. You take 3, substitute 3 minus 2 into 3, positive. 0 to 2 region value, 0 to 2 region, take 1, substitute here, 1 into 1 minus 2, minus. Less than 0, negative, negative product, positive. Then dy over dx variation, positive to negative variation. Then maximum. Negative to positive variation, minimum. Then at 0, at 2, derivatives are 0. No? Therefore, positive to negative variation, local maximum, here local minimum. Then 0, 0, local maximum point, 2, 4 third, local minimum point. Local maximum here and here local minimum. Okay. Now we have only 2 steps to sketch any polynomials. We have only 2 steps again. So here, here this step, finding critical point. Thereafter we have to check x-intercept, y-intercept, and we can sketch the function. Now, under that write down, with star mark write down, when sketching polynomial function, when sketching a polynomial function, further we have to analyze first one y-intercept. We have to analyze y-intercept. Substitute, within bracket write down. To obtain y-intercept, substitute x equals 0 to the function. Okay. Second one, obtain x-intercepts. Within bracket, substitute y equals 0 to the function. Next star mark again. Further, need to analyze variation of y. Further need to analyze variation of y as x tends to plus infinity and x tends to minus infinity. X tends to plus infinity and x tends to minus infinity. We have to analyze 2 things. Okay, let's see what are they. Let's do that for this. Now, here the function y equal x cube over 3 minus x squared. No? First you find x-intercept and y-intercept to complete sketching. Okay, then take x equals 0. Here the function y equal x cube over 3 minus x squared. Let x equal 0, then corresponding y value we get 0. No? When we have substitute x equals 0, y equals 0, this is equal y-intercept. Then thereafter you have to obtain x-intercept. No? Then you take y equals 0 for that. Take y equals 0. Then x cube over 3 minus x square will get 0. Then x cube minus 3x square 0. take x square outside, x minus 3, 0. Then we have x0, x3. These are we call x-intercepts. These are not differentiation. Na? Here substitute x0, find y-intercept. Substitute y0, solve and get x-intercept. Okay, do up to that. Do up to that. Now further you see, then y equal x cube over 3 minus x squared. You have to check here now. As x goes to plus infinity, what will happen for y? And as x goes to minus infinity, what will happen for y? You have to check this. You have to check that one. To complete the graph, you have to check that. So using limits, we have to do that. Then when we evaluate in infinite limit, I told you there, we have to take maximum power term outside. So you take maximum power term outside, that is x cube, take outside. Then 1/3 minus, here this get 1 over x, no? Now you just substitute. When you put x equal plus infinity, let's see what will happen. Then 1 over infinity 0, 1/3 plus infinity cube. Then answer plus infinity. Therefore, as x goes to plus infinity, y goes to plus infinity. Then as x goes to minus infinity, now you substitute minus infinity for x. 1 over minus infinity 0. Here 1/3 remaining. Then minus infinity cube, answer minus infinity. Therefore, as x goes to plus infinity, y goes to plus infinity. As x goes to minus infinity, y goes to minus infinity. Okay. Now to sketch the graph, we have critical points, an intersection point, and terminal tendencies. We have critical points, and we have intersection points and terminal tendencies. We have all relations now. Then we can sketch the function. So here the way, here x-axis, y-axis. First you mark critical point. Here take these 2 points, 0, 0, 2 minus 4/3. 0, 0, 2 minus 4/3. Here 0, 0. Here 2 minus 4/3 somewhere here. First mark them. Those are the points. Then here 0, 0, local maximum, and 2 4/3 local minimum. No? We know maximum shape, maximum, minimum. Then 0, 0, local maximum, then local minimum. Then you complete within this pattern, within this range, you complete the pattern. Then thereafter, you have to continue with this. As x goes to plus infinity, y goes to plus infinity. As x goes to plus infinity, y goes to plus infinity. So you have to sketch this way. So as x goes to minus infinity, here x goes to minus infinity, y goes to minus infinity. No? So as x goes to minus infinity, y goes to minus infinity. That's it. So further, we have y-intercept, y0. It is already there. No? Y-intercept there. Further, we have x-intercept, 0 and 3. Here one x-intercept mentioned in here. Then the other will be 3, no? 3. Okay, that's how we complete the graph. Okay, now you complete that graph. Complete that. Okay, let's do another one. Let's start from the beginning. You do with me. Take this function. You follow all procedure, full procedure you follow. First differentiate, factorize 0, get critical values. Substitute the function and get critical point. Then check dy over dx sign and identify what is that point. Then substitute x0, find y-intercept. Substitute y equals 0, find x-intercepts. Thereafter, consider the function, take maximum power term outside and check tendencies as x goes to plus infinity and minus infinity. Thereafter switch. Okay, that's the procedure. Okay, do with me. Y equal 2x cube minus 5x squared. Y equal 2x cube minus 5x squared. Okay, I'll give you 1 minute to start. You start and proceed. You follow same procedure. First differentiate, then factorize. Y equal 2x cube minus 5x squared. If you have any doubt, do with me. Others do alone. First differentiate 6x squared, 10x. Factorize, take 2x outside, 3x minus 5. Then solve dy over dx 0. Then 2x equals 0. Here x equals 2x times 3x minus 5 0. Then x equals 0 or x equals 5 third. X equals 5 third. Then x0 y value 0. X equals 5 third. Substitute here. 2 times 5 third cube. 5 times 5 third squared. Now you simplify it. Here 5 cube take outside and 3 squared take outside, then remaining 2 third minus 1. Then minus 125 over 27. Here minus 1 third, then minus 125 over 27. Then by this we have critical point 0 0. By these two we have critical point 5 third, comma 125 over 27. These two are critical points. Two critical values. Only function will change, the procedure won't change. You have to practice really well, then it is very easy to get this mark. Differentiate, factorize equal to 0. Check dy over dx sign. So mark critical values 0, 5 third. Greater than 5 third, in between 0 to 5 third, less than 0. Then here you have to check sign here. Here linear factor product, right hand side positive, negative, positive. That's how we take the variation. You can easily do if you have linear factor product, surely right hand corner one will be plus, then minus, plus variation. So here linear factor product with leading term positive. Therefore plus, minus, plus. If you get leading term negative, then sign will be changed. Minus, plus, minus, so on. You better practice to get science directly. Now plus to minus variation, local maximum, minus to plus variation, local minimum. Therefore 0, 0, local maximum, 5/3 minus 125 over 27, local minimum. When x0 y value, so we have obtained that now. Here y intercept, no need to find this, but here we already we know it. Then y intercept. When y equals 0, 2x cube minus 5x cos 0, then take x outside, 2x minus 5 0, we get x equals 0 or x equals 5 over 2. These are x-intercepts. That's how we find x-intercept and y-intercepts. So you have to follow that procedure. Then you take function, take maximum power term outside. Do alone. Think can do. Huh? Then y equal 2x cube minus 5x squared. Take maximum power x cube outside. Then 2 minus 5 over x. Then only we can analyze terminal tendencies as x goes to plus infinity, x goes to minus infinity, y tendency. Here 1 over infinity 0, here plus infinity cube plus infinity, minus infinity cube minus infinity. Now we have variation. So up to now we know critical points and type of the point, x-intercept, y-intercept and tendencies. Now you start sketching. Here 0, 0 local maximum, 0, 0 local maximum. Then 5/3 somewhere here. Corresponding y value minus 125 over 27. You take somewhere here. Minus 125 over 27. Local minimum point. Then complete the pattern. You sketch very smoothly. As x goes to plus infinity, y goes to plus infinity. As x goes to minus infinity, y goes to minus infinity. Here the graph. Sketch graph very smoothly. Then here x-intercept, y-intercept 0 already known, x-intercept 0, 5 over 2. Then 5 over 2 somewhere here. Here the point. 5 over 2. Then very simple thing. Sketch one another. Let's sketch one another. Do with me. Y equal 4x squared minus 16x. Quadratic type. We know how to sketch quadratic function directly using factorization by using complete square. We know how to sketch. But let's sketch this one by differentiation. Okay, continue. dy by dx, 8x minus 16, factorize. Check dy by dx 0, 8 into x minus 2 0, x equal to critical value, then corresponding y value 4 into 2 square, 16 times 2 minus 16. Here 4, 16 minus 32, Therefore, critical point 2 comma minus 16. We have only one critical point. Now you check dy over dx sign. So we have one critical point, that is 2, critical value 2. Then greater than 2, less than 2, sign variation of dy over dx. Greater than 2 positive, less than 2 negative. Then minus to plus, local minimum. Therefore, corresponding to minus 16, local minimum point. Now, when x equals 0, y value, here y intercept, y value 0. When y equals 0, for x square minus 16x 0, here take 4x, x minus 4 0, we have x0, x4, x0 and 4. These are x-intercepts. Here this is y-intercept, and here these are x-intercepts. X-intercept. Now y equal, take maximum power term outside for x square minus 16x now. Then take x square 4 minus 16 of x. Now when x goes to plus infinity, y goes to plus infinity. When x goes to minus infinity, here also y goes to plus infinity. Here 1 over infinity. Here plus infinity square plus infinity, minus infinity square plus infinity. Both are plus. Now we can easily sketch. Here x, y, 2 comma minus 16. Here that point local minimum. Then passing through the origin 0, 0. Now complete the graph. Minimum shape passing through origin. Then as x goes to plus infinity, y goes to plus infinity. As x goes to minus infinity, y goes to plus infinity. Then x-intercepts 0 and 4. Here this will be 4. 4. That's how we sketch. Okay. Now, these are the things about polynomial function sketching. You have to follow only that procedure. That's it. Okay. Then for sketching rational functions, we have to go further 2 steps. We have to analyze asymptote. We have to analyze asymptote. We have 2 different types. One is horizontal one, the other one vertical one. There can be vertical, there can be horizontal. Sometimes they won't be there. But anyway, we have to go further more than this. But we have to follow this procedure when sketching polynomial function and as well as rational function both. Okay. Take small interval. Okay, let's start. Further, we have to sketch more functions. You try. You try y equal 2x cube minus 8x squared. Okay, take this y equal 2x cube minus 8x squared. Follow previous procedure. Follows previous procedure. Dy by dx 6x square 16x 2x common 3x minus 8 dy by dx equals 0 2x times 3x minus 8 0 x 0 8 over 3 x 0 y value 0 here substitute take 8 cube outside here 2 over 27 1 over 9 minus 8 cube over 3 cube minus 8 cube over 3 cube. Now need to simplify. Now critical point we have identified. Then dy by dx sign, you have to check that. Two critical values, first 0, then 8/3. Less than 0 here, we have positive, negative, positive, maximum, minimum. 0, 0 local, maximum point, 8 over 3, minus 8 cube over 3 cube, local, minimum, when x0 y value 0 y intercept, when y0 2x cube minus 8x squared, two x squared take outside, x0 x4 x intercepts. Then take maximum power outside, two minus 8 of x. Then x goes to plus infinity, x goes to minus infinity, y. 0, plus infinity, minus infinity. Then you can sketch. Zero, 0 maximum. Then 8 over 3 minus here 8 over 3 minus 8 cube over 3 cube. As x goes to plus infinity, y goes to plus infinity, y goes to plus infinity, x goes to minus infinity, y goes to minus infinity. Intercept 0, 4. Just 0, 4. Then you try y equal x minus 1 cube y equal x minus 1 cube. Take time and do alone. Here sign variation greater than 1 positive, less than 1 positive. Therefore, positive to positive mean increasing inflection. Increasing inflection. Increasing inflection point. Then previously we obtained maximum or minimum. Now here x greater than 1 sign won't change, x less than 1 sign won't change. Here power 2 no, then sign won't change. All are positive, but x equal 1 is 0. Then positive 0 positive, positive 0 positive, increasing inflection. Now we can sketch the graph. Before that, when x equal 0, y1, here y intercept, y minus 1, no? Y intercept. When y equals 0, x equal 1, x intercept, x goes to plus infinity, y goes to, put plus infinity here, we get plus infinity, x goes to minus infinity, then y goes to minus infinity, minus 1 cube, minus infinity. Now here x-axis, y-axis, first mark critical point, here 1 0, no? 1 0 somewhere here. So at that point, increasing inflection, it goes like this and horizontal, then change. Increasing inflection. Then as x goes to minus infinity, y goes to minus infinity, x goes to plus infinity, y goes to plus infinity. Here y-intercept, minus 1, no? Minus 1. That's the graph. First you identify by differentiation critical point, then by the sign you check whether it is positive or negative, okay, whether it is maximum or minimum, and thereafter sketch. Okay, now try this. Now try this. Y equal x to the power 5 over 5 minus x cube over 3. X to the power 5 over 5, x cube over 3. Continue. Dy by dx 5x to the power 4 over 5 3x squared over 3 x to the power 4 x square, take x square outside, factorize further, we need this, then solve dy over dx to 0 equals 0. So here three critical values, x equals 0, x equals -1 and x equals +1. Corresponding y values substitute 0, then substitute +1, 1/5 minus 1/3. Then minus 2 over 15, 3, 5. Then here plus 2 over 15. Now critical points known, 0, 0, -1, 2 over 15, 1, minus 2 over 15. Critical point. Here critical values. Then you check dy over dx sign. -1, 0, 1. Then only sign change at +1 and -1. Here and here only sign change, because here x gone, then at x equals 0 sign won't change. Then here leading term positive, therefore we can start from here positive, then negative, no sign change, negative, here positive. Or otherwise you put values and check the sign. Plus to minus maximum, minus to minus decreasing inflection, minus to plus minimum. Therefore -1, -1, 5, 2 over 15. Local maximum 0, 0, decrease in inflection, and 1, minus 2 over 15. Local minimum. Then find intercepts. When x0, y value 0. When y0, x value. Before that you have to solve x to the power 5 minus x cube over 5, 3, 0, take x cube outside, then 3x square minus 5, here x equals 0, x square equal 5/3, square root plus or minus 5/3. We have three interceptions. Here x squared equal 5/3, then x equal plus or minus 5/3 root. 5/3 root. Now we have to check only infinity cases. X, y equal, take x to the power 5 outside. Three x squared. X goes to plus infinity, y goes to plus infinity, x goes to minus infinity, y goes to minus infinity. Then start sketching the function. Here 0, 0 critical point, -1, 2 over 15, critical point, it's local maximum, then here decreasing inflection, it goes like this. Then here 1, local maximum, minus 2 over 15. As x goes to plus infinity, y goes to plus infinity, x goes to minus infinity, y goes to minus infinity. X-intercept 0, plus or minus 5 over 3 rule. Minus 5 over 3. Here you have only only simple function, okay? When differentiation very simple, okay? Then when sketching graph, you won't get any difficult functions. Y equal 27 minus 54x plus 36x square minus 6x cube, right? Dy by dx minus 54, 36 times 2x, 6 times 3x squared. Here 9 common. Take 9 outside. Minus 9, 2x square, 8x, 6. Again 2 common. Now factorize. X 3 1 minus minus. Then dy by dx 0 case. Minus 18 x minus 1 x minus 3 equal 0, x equal 1 x equal 3, x equal 1 y value. Here find y value. Here 27 minus 54 plus 36 minus 6. Now you simplify. Here minus 27 plus 9 plus 3. Minus 27 plus 9 plus 3. X equals minus 3. 27 plus 3, 27, 54 times 3, 36 times 9, 6 times 27. Then get the value. take 18 outside, so 9 outside, 3, 18, 36, minus 18. $27. 1, 3, 3, 27. Here, critical point. Here, these two critical values. Critical values. When x equals 0, y value 27. When y equals 0, 27 minus 54x, 36x squared, 6x cubed, 0. Then this is divisible by 3 now. Minus 2x cubed, 12x squared, 18x, 9. Then get factors. මෙතන factors සමාරුවෙන් හොන් දඟලන්න එපා අනිත් ටික complete කරමු. එකක් විතර තමයි පේන්න තියෙන්නේ. අපි බලමු එක. Critical point 1, 3. dy over dx sin එක check කරලා නැහැ නේ. Okay, now check the sign. dy over dx sin zero 1 3 no 1 3 negative, positive, negative. One, 3. Minimum. Then 3. 27. Maximum. X0 y value 27. Then here x, there is only one x intercept. Here we have only one factor. See 9 divided by 2. I think this will be the factor. Here 2x minus 9. This can be the factor. Nine over 2, 3 over 2. එක හොයන්න දකරන්න එපා. දැන්ට කමන්න. පස්සේ වෙනම ගන්න. Okay, then you try y equal 3x to the power 4 minus 16x cube plus 18x squared. Okay, take it. dy by dx 3 into 4x cube 16 into 3x square 18 into 2x. Now you take common multiple outside. Here 6x common, take it outside. Here 2x squared 8x 6. Here 6x, 2x square, 60, 3 into 2, 8. Then 3 into 2, 6. Again 2 common. 12x, x square minus 4x plus 3. Factors x, x, 3, 1, minus, minus. dy by dx equals 0. 12x into x minus 1 into x minus 3, 0. X equals 0, 1, 3. X0 y value 0. X1 y value here 3 minus 16 plus 18. Here 2, 5. Then x equal 3 value, 3 y value, here 3. 81 times 3, 243. 27 times 16. 18 times 9. Here 3 times 3 to the power 4. No? Here 9, 3 cube, common, take it outside. Then 9 minus 16 plus 2. 5, 3 cube. 27 times 5. 135. 135. Minus 135. Minus 135. Check the values, huh? Here minus 27. 0, 0, 1, 5, 3 minus 27. These are critical point. Now check dy over dx sign. Zero, 1, and 3. Then leading term positive, no? Then plus minus variation, minimum, maximum, minimum. Therefore, 0, 0 local minimum, local maximum, local minimum. When x0 y value 0, when y0 3x to the power 4, 16x cube, 18x square 0, take x square outside, 3x square, 16x plus 18, 0, try to factorize. Three x 9, 2 minus 3x square minus 6 minus 9 minus 16 plus 18. Okay. Then x equals 0, x equal 9 over 3. Something wrong, no? Something wrong. On the factors theta? No. X square 0, 3x square minus 16x plus 18. X equal minus b plus or minus b square minus 4ac root divide by 2a. Okay, no need to simplify, no need to simplify for now. Then take x to the power 4 outside. Three minus 16 of x, 18 of x squared. X goes to plus infinity, y plus infinity, x goes to minus infinity, y plus infinity, both plus infinity. Now you sketch. Zero, zero, minimum, 1, 5. Maximum, then 3 minus 27. Minimum. That's it. Then identify the function can be different, but the procedure won't change. It is fixed. Then for quadratic, there can be local maximum or local minimum. For cubic, maximum and minimum. And biquadratic, usually maximum, minimum, maximum or maximum, minimum, maximum, minimum. Two maximums, one minimum, one maximum, two minimum. Those possibilities can. Then for perplex powers, like x minus 1 to the power 3 or greater than 3. So that can get inflections. For repeating factors greater than 3, usually 3 and greater than 3, usually we get repeating factors get inflections, increasing inflection or decreasing inflection. Anyway, so by this procedure we can track them. Everything we can track. Y equal x cube minus x square minus x plus 3, right? Let us find factors. Now let's do one special type question. You have to think and do here. Write this one. Write this one. If the function, write down, if the function y equal x square plus ax plus b, if the function y equal x squared plus ax plus b has a turning point 1, 3, x squared plus ax plus b has a turning point 1, 3, find AB. Find AB. Find A and B. Okay, you think and try. Okay, here it is. Here this is turning point. So at the turning point, derivative 0, no? Equal 0 at x equal 1. At x equals 1, dy over dx 0. Then you differentiate dy by dx 2x plus a. So when you substitute dy by dx, x equal 1 corresponding value will be 0 because this is turning point. Then a value minus 2. So this point on the curve, no? This point on the curve, your turning point 1, 3. Therefore, when you substitute 1 here, you will get 3. Here 1, 3, no? When you substitute x 1 for x, then y value will be 3. 1, 3 is on the curve. Therefore, substitute y value 3, x value 1. Here 2, a value minus 2 plus b, b value 4. A equal minus 2, b equal 4. Analyze the concept. Turning point concept, turning point means critical point, derivative 0. At that point, derivative 0. Then you differentiate. When you substitute x equal 1, the result will be 0. Then that point on the curve, therefore you can substitute x equals 1, then corresponding y value will be 3, no? 1, 3. Now I gave you a tutorial. So here you can do See page number 4. Page number 4. Tangents and normal thing we have done. Page number 4, tangents and normal you can complete. 2 weeks before we did that. Then page number 6, increase in functions, decrease in functions and graph. You can do that, increase in function, decrease in function part. Then page number 8. Page number 8. You can do up to some level. Do only question number 55. And application of derivative plus in real life part, page number 9, you can try, yeah? You can try. So under application of derivatives, we do more questions after doing this graph part. So we have to complete only inequality verification by differentiation thing and rate of change. So inequality verification will not be your A-level question, and rate of change also not for your A-level questions, but we have to analyze them. Then next week we can complete this graph part. So we done up to some level. So now we can sketch any polynomial type. Then we need to analyze only rational type. Huh? That's it.